What if time is not a river, but a flexible dimension? Imagine bending time the way you bend a simple sheet. Physics suggests time might not flow as we always believe. Scientists have questioned time's nature for over a century now. The journey begins with a genius named Albert Einstein. He changed how humanity understands space, time, and reality forever. His theory of relativity introduced a shocking new perspective. Time was no longer absolute, but deeply connected with space. This concept became known as space-time, a unified cosmic fabric. Objects moving through space also move through time simultaneously. The faster you move, the slower your time actually passes. This strange effect is called time dilation in physics. It sounds unbelievable, but experiments have proven it repeatedly. Even astronauts experience tiny amounts of time travel in orbit. Their clocks tick slightly slower compared to people on Earth. Gravity also plays a major role in time's behavior. Stronger gravity slows down time more significantly than weaker gravity. Near massive objects, time almost comes to a dramatic halt. Black holes are perfect examples of extreme gravitational effects. Around them, time behaves in ways almost impossible to imagine. A person near a black hole would age much slower. Meanwhile, distant observers would see their time nearly frozen. This creates a natural form of traveling into the future. You cannot return, but you can skip ahead in time. This is forward time travel, supported strongly by modern physics. But what about traveling back into the past instead? That idea is far more complex and controversial among scientists. Some theories suggest it might be possible under certain conditions. One such concept involves mysterious cosmic structures called wormholes. Wormholes are theoretical tunnels connecting distant points in space-time. They could act like shortcuts across both space and time. Imagine entering one point and exiting in a different era. It sounds like science fiction, but physics allows the possibility. However, no wormhole has ever been observed or confirmed. Even if they exist, keeping them stable is extremely difficult. They would require exotic matter with negative energy properties. Such matter has never been discovered in practical amounts. This makes backward time travel highly speculative and uncertain today. Another idea involves rotating black holes and their strange properties. These objects might twist space-time in unusual and unpredictable ways. Some equations suggest closed loops in time could form there. These loops are called closed time-like curves in physics. They might allow a traveler to return to their past. But this creates dangerous logical problems known as time paradoxes. One famous example is the grandfather paradox dilemma. What happens if you prevent your own existence in the past? Would you disappear, or would reality adjust itself somehow? Physicists debate these questions without clear or final answers. Some believe the universe prevents paradoxes from ever occurring. This idea is known as the self-consistency principle. It suggests events in time are fixed and cannot be changed. Others believe in multiple timelines or parallel universes instead. In that case, changing the past creates a new timeline. Your original timeline would continue unaffected by your actions. This concept connects with quantum mechanics and multiverse theories. However, these ideas remain unproven and highly theoretical today. Time travel challenges our understanding of reality at every level. It forces us to rethink causality, existence, and the universe. Physics provides clues, but many mysteries still remain unsolved. Scientists continue exploring these possibilities with advanced research and experiments. New discoveries may change everything we believe about time itself. Perhaps time travel will become reality in some distant future, or maybe it will always remain a fascinating theoretical concept. Either way, the journey into time's secrets has just begun, and the deeper we go, the stranger everything becomes. What if time itself could be manipulated like energy or matter? Scientists believe motion plays a key role in bending time. The faster an object moves, the slower its time progresses. This effect becomes dramatic near the speed of light. Light speed is the ultimate cosmic limit in physics. Nothing with mass can reach or exceed this speed. As you approach it, time nearly stops for you. This creates a doorway into the distant future effectively. A traveler could return to find centuries already passed. This idea is not fiction, but scientifically verified reality. Particle accelerators demonstrate time dilation effects at tiny scales. Subatomic particles live longer when moving at high velocities. Their internal clocks slow down compared to stationary observers. This proves time travel into the future is physically possible. However, reaching such speeds for humans remains a massive challenge. The energy required would be unimaginably large and complex. Spacecraft would need revolutionary propulsion systems beyond current technology. Some scientists imagine using antimatter as a powerful energy source. Antimatter releases enormous energy when it meets normal matter. This could potentially fuel near-light-speed travel in future missions. Another concept involves massive rotating cylinders in deep space. These structures might simulate extreme gravitational effects artificially. Inside them, time could slow relative to the outside world. This would create controlled forward time travel environments for humans. But building such structures is far beyond current capabilities. Physics allows these ideas, but engineering makes them nearly impossible today. Gravity remains another powerful tool for manipulating time itself. The stronger the gravitational field, the slower time flows. Near dense stars, time noticeably slows compared to Earth's surface. Around black holes, this effect becomes incredibly intense and extreme. A region called the event horizon marks the critical boundary. Beyond it, nothing can escape. Not even light itself. Observers outside would see time freeze near this boundary. For the falling traveler, time continues normally from their perspective. This difference creates strange illusions between observers and travelers. It demonstrates how time is relative, not absolute or fixed. The theory explaining this is called general relativity. It describes how mass and energy curve space-time dramatically. This curvature affects how objects move and how time behaves. Massive bodies create deeper curves, slowing time more significantly. Smaller objects create weaker curves with minimal time distortion effects. This relationship between gravity and time is fundamental in physics. It opens the door to controlled time manipulation ideas, but it also introduces risks beyond our current understanding. Extreme environments like black holes are incredibly dangerous for humans. The forces near them could tear objects apart instantly. This effect is known as spaghettification in astrophysics discussions. It stretches objects into long, thin shapes due to gravity differences. Surviving such conditions would require unknown protective technologies. Even observing these regions closely is extremely difficult today. Telescopes provide indirect evidence of these extreme time effects. Scientists continue studying signals from distant cosmic phenomena carefully. Each discovery brings new insight into time's hidden behavior. The universe itself acts as a giant laboratory for time experiments. Every star, planet, and galaxy contributes to understanding time. Yet, many questions remain unanswered in modern physics theories. Could we ever control time as easily as space travel? Or will time always remain beyond our practical reach forever? The answers may lie in future breakthroughs and discoveries ahead. New technologies could transform theoretical ideas into real possibilities someday. Humanity's curiosity continues driving exploration beyond known limits. Time travel remains one of the most fascinating scientific challenges. It connects physics, philosophy, and imagination into one mystery, and every answer seems to create even deeper questions. The journey through time is only becoming more intriguing now. What if the past is not gone, but still exists somewhere? Some physicists believe time may exist all at once simultaneously. This idea is known as the block universe theory. In this view, past, present, and future already coexist together. Time becomes a dimension similar to length, width, and height. We simply move through it in one constant direction. But what if that direction could somehow be changed? This question leads scientists into deeper and stranger theories. One possibility involves bending space-time into loops or circles. These loops could allow a return to earlier points in time. Such paths are called closed time-like curves by physicists. They emerge naturally from equations in general relativity theory. The foundation of this theory was developed by Albert Einstein. However, solutions allowing time loops require very unusual conditions. Rotating universes or infinitely long cylinders might create such effects. One example is the Tipler cylinder theoretical model. It suggests a massive rotating object could twist time around itself. Traveling near it might send someone into their own past, but constructing such an object is practically impossible today. It would require infinite length or unimaginable density and energy. Another fascinating idea comes from cosmic strings in space. These are hypothetical defects formed during the early universe expansion. They could carry enormous mass packed into incredibly thin structures. If two cosmic strings passed each other, time loops might form. This could theoretically create pathways into the past. Yet no cosmic string has ever been directly observed. Their existence remains purely speculative within modern physics discussions. Quantum mechanics also introduces strange possibilities for time behavior. At very small scales, particles do not follow normal rules. They exist in probabilities rather than definite positions or paths. Some interpretations suggest time could behave unpredictably at quantum levels. This opens doors to unusual effects that defy classical understanding. One idea involves quantum entanglement across time itself. Particles might influence each other even across different moments. This challenges our traditional concept of cause and effect relationships. It raises questions about whether time truly flows forward only. Could effects sometimes occur before their actual causes happen? This idea seems impossible, yet physics does not fully reject it. Another theory involves the concept of tachyons, hypothetical faster-than-light particles. If they exist, they could move backward through time naturally. However, tachyons remain purely theoretical without experimental confirmation today. Most scientists remain skeptical about their real existence in nature. Time travel to the past also creates serious logical contradictions. These contradictions are known as time travel paradoxes. The grandfather paradox is the most famous example discussed widely. It questions whether changing the past could erase your own existence. Another paradox is the bootstrap paradox, equally puzzling and confusing. It involves objects or information existing without a clear origin. Imagine receiving knowledge from your future self with no beginning. This creates a loop with no starting point in time. Such paradoxes challenge the consistency of physical laws entirely. To resolve this, some theories suggest strict limitations on time travel. One proposal is the chronology protection conjecture by Stephen Hawking. It argues that the universe prevents time paradoxes from occurring naturally. According to this idea, laws of physics forbid backward time travel. Another approach suggests parallel universes solving paradox problems completely. Changing the past would create a new separate timeline instantly. Your original timeline would remain unchanged and continue independently. This aligns with interpretations of quantum mechanics and multiverse theories. However, there is no experimental evidence supporting this idea yet. Time remains one of the least understood aspects of physics. Every theory reveals new mysteries instead of clear answers. Scientists continue searching for a unified understanding of time itself. The deeper they explore, the stranger the universe appears, and the possibility of time travel remains both exciting and uncertain. What if the universe hides secrets that make time travel inevitable? Some scientists believe time travel may emerge from quantum gravity theories. This field tries to unite relativity with quantum mechanics successfully. Both theories describe reality, yet they conflict at fundamental levels. Resolving this conflict could unlock deeper truths about time itself. One major candidate is string theory, a highly complex framework. It suggests reality consists of tiny vibrating strings of energy. These strings exist in multiple dimensions beyond our perception. Some versions propose up to 11 dimensions in total. Extra dimensions might allow shortcuts through space-time itself. These shortcuts could potentially enable forms of time travel. However, string theory remains unproven despite decades of research. Another approach is loop quantum gravity, offering a different perspective. It suggests space-time is made of tiny discrete units. Instead of being smooth, space-time may have a granular structure. At extremely small scales, time might behave very differently. This could lead to unusual effects, including possible time loops. Scientists are still developing and testing these advanced theories carefully. The early universe may also hold clues about time's nature. Right after the Big Bang, conditions were extremely energetic and chaotic. Physics behaved differently under such extreme temperatures and densities. Time itself may have functioned differently during those early moments. Studying this period could reveal hidden properties of time. Cosmic background radiation provides valuable evidence from that era. Researchers analyze it to understand the universe's earliest stages. Every discovery adds pieces to the puzzle of time. Advanced experiments also attempt to simulate extreme conditions on Earth. Particle colliders recreate tiny versions of high-energy cosmic environments. These experiments help scientists test theories about time and space. Though limited, they provide important insights into fundamental physics. Technology continues advancing, opening new possibilities for future research. One day, we may manipulate space-time more precisely than ever. This could lead to controlled experiments involving time itself. However, ethical questions would arise alongside such powerful discoveries. Should humanity interfere with time if it becomes possible? The consequences could be unpredictable and potentially dangerous. Changing events might affect entire histories and future outcomes. Even small actions could create massive ripple effects across time. This idea is often called the butterfly effect in chaos theory. It suggests tiny changes can lead to enormous consequences. Time travel could amplify this effect beyond our imagination. This makes controlling outcomes extremely difficult, if not impossible. Scientists must consider these risks when exploring time manipulation ideas. Responsibility becomes crucial when dealing with such powerful concepts. Fiction often explores these dilemmas through imaginative storytelling, but real-world physics requires caution, precision, and evidence-based conclusions. Despite challenges, curiosity continues pushing scientific boundaries forward. Each generation builds upon the discoveries of those before them. Future scientists may achieve breakthroughs we cannot even imagine today. Time travel could become a reality far beyond our era, or it may remain a theoretical dream guiding scientific exploration. Either way, studying time deepens our understanding of existence itself. It connects physics with philosophy and human curiosity profoundly. Questions about time shape how we see life and reality. Are we bound by time, or is time bound to us? The answer remains hidden within the universe's deepest mysteries. Researchers continue exploring with dedication and innovative thinking. New tools and ideas will shape the future of physics. Time may reveal its secrets gradually through careful investigation, or it may surprise us with sudden, revolutionary discoveries. The journey is as important as the final answers themselves. Every step forward brings humanity closer to understanding time, and perhaps one day, even mastering its hidden dimensions. Until then, time travel remains both science and imagination combined, and the final piece of this mystery is still waiting ahead. What if the future already exists, waiting quietly for us? Physics suggests time may not be as simple as we perceive. Our experience of time could be an illusion of consciousness. Some scientists believe the present moment is not truly special. All moments might exist equally across the fabric of space-time. We simply move through them in a fixed forward direction. But future technologies might challenge this seemingly fixed direction. Imagine navigating time like we navigate across physical space today. Such control would redefine humanity's relationship with reality completely. However, enormous scientific barriers still stand in our way. Energy requirements alone make practical time travel extremely difficult. Stabilizing wormholes would require forms of matter never discovered. Even creating tiny time loops remains beyond our current abilities. The laws of physics might impose strict limits on time travel. One concept is causality, the relationship between cause and effect. Breaking causality could lead to contradictions within physical reality. This is why backward time travel remains highly controversial. Some physicists argue it may never be physically possible. Others believe hidden solutions may exist within undiscovered physics. The search for a unified theory continues across the world. Combining relativity and quantum mechanics could unlock new possibilities. This theory is often called the theory of everything. It aims to explain all forces and particles consistently. If successful, it might clarify whether time travel is achievable. Until then, experiments continue pushing the limits of knowledge. Observations of distant galaxies provide clues about time's behavior. Light from these galaxies shows us the universe's past. In a way, astronomy already allows us to see back in time. The deeper we look, the further into history we observe. This makes the universe a natural time machine of observation. However, interacting with the past remains beyond our reach. Future time travel seems more realistic based on current physics. High-speed travel and strong gravity can shift time forward. Astronauts already experience tiny versions of this effect daily. Over long periods, these differences could become significantly noticeable. This raises fascinating possibilities for long-duration space missions ahead. Travelers could return to a future far beyond their departure time. Society, technology, and culture would have drastically changed meanwhile. This creates emotional and philosophical challenges for time travelers. They would become visitors in a world they barely recognize. Time travel is not just physics, but a human experience too. It forces us to think about identity, memory, and existence. Would you remain the same person across different times? Or would time reshape your understanding of yourself completely? These questions extend beyond science into deep philosophical territory. Physics provides the tools, but meaning comes from human reflection. Time connects everything in the universe through cause and change. Understanding it means understanding reality at its deepest level. Each discovery reveals how complex and mysterious time truly is. Even with advanced theories, many aspects remain unexplained today. Scientists continue exploring with curiosity and relentless determination. New ideas will shape the future of time research significantly. Perhaps one breakthrough could change everything we currently believe, or the truth might be more subtle than expected. Time travel may exist, but in ways we do not expect. The universe often surprises us with unexpected and elegant solutions. What seems impossible today may become possible tomorrow. Humanity's journey through knowledge is far from complete. Time remains one of the greatest mysteries we seek to understand, and the quest to master it continues across generations. Whether possible or not, time travel inspires endless curiosity. It pushes science to explore beyond known limits courageously, and it reminds us how little we truly understand reality. The story of time is still being written by science, and perhaps one day we will become part of it.